Of course, not all triangles are right angled, so we need a couple of rules to help us solve problems where triangles are not right angled. The sine rule, which you may recall. And the way we find it, the way we create it, I drop a perpendicular, call it h for height. Now, using normal right angled triangle trig, I can say, well, look, h over c is the sine of beta. Or not beta, b, sine of b. And h over b would be the sine of c in that other triangle. Well, therefore, c sine b must equal b sine c, because they're both equal to h. And that's where we get our sine rule from. So c on sine c is b on sine b. And of course, I could have just as easily have done it with the angle A as well. So in any triangle, A over sine A, B over sine B, C over sine C, which is actually equal to something else. A over sine A equals B over sine B equals C over sine C equals the diameter of the circumcircle. Circumcircle. Circum means go round. So the circle that goes around all three vertices, that would be the diameter of that particular circle. Okay. So, typical sort of question. We've got two angles in the triangle. We've got one side. We need to find a second side. So we set it up. In this case, it'll be h on sine h is q on sine q. Substitute in, and it's just calculator work really. Now, I usually match what the question does. If they don't tell me how to round off, and I notice they've given me the side to 1 decimal place, so it makes sense to give my answer to 1 decimal place, 45.8. If I want to use it to find an angle, then I just turn it upside down and put the angle on top. So for this one, I'll say sine y on y is sine z on z. Again, substitute in the numbers we know, rearrange, and there we go, 46 degrees, 58. So where you got to be careful, because sine of acute angles are positive, that is true. But so are the sine of angles between 90 and 180. So is it possible that your angle could be obtuse? Your calculator doesn't know, you're just punching numbers in. It's going to assume that it's acute. So you need to just check with some of these, does the answer make sense? So what could make it obtuse? Think of things like this. We know the angle sum of a triangle is 180. So if by making it obtuse, the angle sum goes over 180, well clearly it can't be that, so it would be acute. In any triangle, the largest angle is always opposite the largest side. Smallest angle is opposite the smallest side for that reason as well. So again, you could see, have a look at the measurements to say, well, actually, am I expecting the largest angle? In that case, it might be obtuse. Here's the bit about the circumcircle. So there's ABC. We put a circle around the triangle. That's the circumcircle. That is our sine rule. A over sine A, B over sine B, C over sine C, the diameter of the circumcircle. We can prove it using circle geometry. We also have another formula for area of a triangle, because we might not know the perpendicular height. Sure, we've got half base height, simple little formula, but if we don't have the perpendicular height, we can use this one. I'm going to drop in that perpendicular height that I don't know, so I'll just call it h, because I don't know what it is. We know area half base height, fair enough. But again, using right angle triangle trig, I could say, well, h on b is sine c, so therefore h is b sine c, substitute that back in to half base height, and I get half ab sine c. So I don't actually need to know the perpendicular height. The b sine c part of that formula is working out the perpendicular height for me. So we could have half ab sine c. Again, it just depends on which angle you know. Half BC sine A, half AC sine B. Basically, it's got to be an angle which is included in the two sides that you know. So let's do a quick one there. That's the situation. Yes, I've got two sides and the included angle, so I can use that formula. in this case half dm sine f, sub in, and just a bit of calculator work. 25.47 in this case. Okay, that'll do us.